What is a star? At its core, a star is a massive, glowing sphere of hot gas, mainly hydrogen and helium, held together by gravity. Deep inside, nuclear fusion fuses hydrogen into helium, releasing energy as light and heat. Our Sun is a typical example, a middle-aged G-type star powering life on Earth. Nearly every point of light in the night sky is another star, each with its own size, color, and temperature. Some stars burn blue and hot, others red and cool, but all are cosmic furnaces, turning mass into energy. Astronomers study starlight with telescopes and spectrographs, decoding a star's temperature, composition, and motion. Stars are classified by spectral type O, B, A, F, G, K, M, ranging from the hottest, most massive O types to the coolest, smallest M types. Our Sun sits in the middle as a G type. This classification helps us map the life cycles of stars, from their birth in clouds of gas to their spectacular deaths. Some stars are common, others are rare, true cosmic oddities. The rarest stars are the ones that push the boundaries of what's possible in the universe. They're the outliers, the exceptions, and the most fascinating mysteries in the stellar zoo. Understanding them helps us unlock the secrets of the cosmos. So, what makes a star truly rare? Rarity among stars is all about cosmic odds. Most stars are small, cool red dwarfs, so common they're nearly invisible to the naked eye. Massive, brilliant blue stars are rare because they require enormous gas clouds to form and burn out quickly. These giants live fast, die young, and vanish in cosmic blinks. Some rare stars are actually stellar remnants, neutron stars, black holes, the exotic corpses left after a star's explosive death. These objects are rare because only the most massive stars become them, and their unique phases are fleeting. Others, like ancient white dwarfs or brown dwarfs, are rare simply because they're so faint and hard to spot. Finding these rare stars is like searching for a single grain of sand on a beach. Astronomers scan the sky for unusual flickers, radio signals, or X-ray bursts, clues to something extraordinary. Each rare star is a cosmic treasure, revealing new extremes of physics and stellar evolution. The hunt for them is a grand adventure, pushing the limits of our technology and imagination. Let's explore some of the rarest stars in the universe. When a star like our Sun runs out of fuel, it sheds its outer layers and leaves behind a dense core, a white dwarf. Imagine the Sun's mass compressed into a sphere the size of Earth. A teaspoon of this material would weigh tons. White dwarfs no longer fuse atoms. They glow from leftover heat, slowly cooling over billions of years. Their incredible density is held up by quantum pressure, not fusion. Most stars, including our Sun, will end as white dwarfs, but the rarest are the oldest, coldest ones, nearly invisible in the darkness. Over unimaginable time, a white dwarf could become a black dwarf, a cold, dark cinder, but the universe isn't old enough for any to exist yet. Some white dwarfs in binary systems siphon material from companions, triggering spectacular novae or even supernovae. These explosive events are rare and brief but crucial for understanding cosmic chemistry. White dwarfs are the ghosts of stars past, and their most extreme forms are among the hardest objects to find. They remind us that even in death, stars can shape the universe. Next, let's meet their even stranger cousins, neutron stars. The stellar graveyard is full of surprises. Let's go deeper. Neutron stars are born from the explosive deaths of massive stars, supernovae. The core collapses, crushing protons and electrons into neutrons, forming an object denser than anything else except black holes. Picture the Sun's mass squeezed into a sphere just 12 miles wide. A single sugar cube would weigh 100 million tons. Gravity here is so intense, you'd be flattened instantly. Many neutron stars spin rapidly, emitting beams of radiation from their magnetic poles. If these beams sweep past Earth, we detect them as pulsars, cosmic lighthouses flashing in the dark. Most neutron stars are invisible unless their beams point our way or they interact with a companion star. Some are found by their faint X-ray glow or by the way they warp nearby objects. Neutron stars are rare, extreme, and mysterious, true phantoms of the cosmos. They push the limits of physics, challenging our understanding of matter and gravity. But there's an even more extreme version, the magnetar. Let's meet the universe's magnetic monsters. The story only gets stranger. Magnetars are the rarest, most extreme neutron stars. Their magnetic fields are a quadrillion times stronger than Earth's, so powerful they can warp atoms and erase data from a distance. These fields twist and stress the star's crust until it cracks, unleashing violent starquakes. In a split second, a magnetar can release more energy than the sun produces in hundreds of thousands of years. Their high-energy lives are brief, just 10,000 years, making them incredibly rare. Only a few dozen have been found in our entire galaxy. We spot them by their giant flares of X-rays and gamma rays, brief, brilliant flashes in the darkness. Magnetars are cosmic beasts, challenging the very limits of physics. They remind us that the universe is stranger than we can imagine. Now let's return to the living, the Wolf-Rayet stars. Some stars burn so brightly they tear themselves apart. Wolf-Rayet stars are massive, hot, and short-lived, true rock stars of the cosmos. With at least 20 times the sun's mass and surface temperatures over 50,000 Kelvin, they shine millions of times brighter than our sun. Their intense light drives powerful stellar winds, blasting away their outer layers at millions of miles per hour. In just a few 100,000 years, they can lose as much mass as our sun contains. This process exposes their inner layers, rich in helium, carbon, and nitrogen. Their unique light signatures, bright emission lines, set them apart. The Wolf-Rayet phase is a brief, final act before a massive supernova. Only the most massive stars become Wolf-Rayets, making them exceptionally rare, just a few hundred in our galaxy. Finding one is like spotting a flower that blooms for a single day. They are beautiful, violent, and fleeting, but some stars are rare for stranger reasons, like the blue stragglers. Blue stragglers are cosmic mysteries, hot blue stars found in old star clusters where only old cool stars should remain. They look young, but are actually old stars rejuvenated by unusual events. One theory, two stars collide and merge, creating a new, hotter star with fresh fuel. Another, in a binary system, one star siphons material from its companion, becoming hotter and bluer. A kind of stellar vampirism. These scenarios are rare, requiring dense star clusters and close encounters. Blue stragglers defy the usual rules of stellar aging, standing out as youthful outliers among ancient neighbors. They're most common in globular clusters, where stars are packed tightly together. Each blue straggler is a clue to the chaotic dynamic history of star clusters. They challenge our understanding of how stars live and die. Rare stars like these are more than curiosities, they're keys to cosmic mysteries. Why do we hunt for them? Why search for rare stars? Because they're natural laboratories, pushing physics to its limits. In neutron stars and magnetars, matter behaves in ways we can't replicate on Earth. These objects test our theories of gravity, quantum mechanics, and magnetism. Rare stars also forge the elements that make up planets, life, and everything we know. Heavy elements like gold and uranium are born in the cataclysmic collisions of neutron stars. Studying rare, massive stars helps us understand the cosmic cycle of birth, death, and rebirth. Supernovae and stellar winds seed the galaxy with the building blocks for new stars and worlds. Each rare star is a signpost in the story of the universe. Our curiosity drives us to seek them out, to ask how the cosmos works and where we fit in. Every discovery adds a piece to the puzzle of existence. The search for rare stars is a journey into the unknown. From white dwarfs to magnetars, the universe is filled with rare and spectacular stars. They are the exceptions that reveal the rules, the outliers that expand our knowledge. Born from chaos, living violently and dying in explosions, they shape the cosmos and our own origins. With new telescopes and technology, we're seeing deeper and clearer than ever before. We now study the universe in radio waves, X-rays, and even gravitational waves, unlocking secrets once hidden. The next time you look up at the night sky, remember, for every star you see, billions more are out there. Some common, some rare, all part of a grand cosmic story. Among them are stellar ghosts, magnetic monsters, and cosmic diamonds. You're witnessing the universe's history and your own cosmic heritage. The quest for knowledge is endless. There's always another mystery waiting beyond the next star. Stay curious, keep asking questions, and never lose your sense of wonder. The universe is the greatest story ever told, written in starlight. So, every once in a while, just look up. the cosmos, awaits.